So you pull out your phone to take a photo, you tap the button and boom, you have a picture. But what's actually happening inside? The magic starts with something called a camera sensor. Think of it as the digital version of film from an old-school camera. It's a small chip, usually a rectangle. It's covered in millions of tiny light-sensitive dots. Those are called photosites. Those are also what we call pixels. When you point your camera, light travels through the lens. That light hits the sensor. Each tiny dot captures a small piece of the overall image. This sensor is arguably the single most important part of any digital camera. For example, a huge professional rig, or the tiny camera on the front of your smartphone. The quality of the sensor directly impacts the quality of your final photo. A bigger sensor can hold larger pixels. Larger pixels collect more light. More light equals a cleaner, brighter image. Back in the early days of smartphones, camera quality was okay at best. Photos were often blurry, grainy, and struggled badly in anything but perfect bright sunlight. Then, around 2011, Sony introduced the first of its IMX series sensors, the IMX-135. This wasn't just another sensor, it was a statement. It featured a new technology called a stacked CMOS design. Before this, all the parts of a sensor, the pixels and the circuits that process the signal, were on the same level. Sony's stacked design was brilliant in its simplicity. They separated the sensor into two layers, or wafers. The top layer was dedicated entirely to the pixels, the part that actually sees the light. The bottom layer held all the processing circuits. By stacking them, Sony freed up a ton of surface area on the top layer, allowing them to make the pixels bigger and more effective at capturing light. This immediately resulted in photos that were cleaner, had better color, and showed significantly less noise in low-light conditions. This breakthrough was a huge deal. Suddenly, smartphones had a path to capturing images that could rival dedicated point-and-shoot cameras. The IMX-135 and the sensors that followed it quickly became the gold standard in the mobile industry. After the success of their first stacked sensors, Sony didn't slow down. They went into a cycle of constant improvement, making their IMX sensors better with each generation. One of the biggest trends was, quite literally, making the sensors bigger. 1 over 2.3 inch, 1 over 1.7 inch, 1 inch type sensors in flagship phones. A larger sensor area allows for larger pixels, which is the key to capturing more light. This is why modern smartphones have such impressive low light and night mode capabilities compared to phones from just 5 or 6 years ago. But it wasn't just about size. Sony got smarter with the technology on the chip itself. They introduced features like on-chip phase detection autofocus, or PDAF. This put special autofocus pixels directly onto the sensor, enabling near-instant focus just like a high-end mirrorless camera. Then came the megapixel race, but with a twist: quad-Bayer pixel binning. A 48-megapixel sensor could group 4 adjacent pixels into one superpixel. In bright daylight it uses all 48 million pixels for detail. In low light it combines them to act like a 12-megapixel sensor with huge pixels. This relentless innovation is why Sony has maintained its lead. Apple, Google, Samsung, many other smartphone brands. Even when companies design their own camera software, the hardware foundation is often a Sony IMX sensor. So, where do we go from here? The physical size of sensors in phones is getting close to its practical limit. You can only make the camera bump so big before the phone becomes a brick. The next frontier for Sony IMX sensors isn't just about hardware, it's about integrating intelligence directly onto the chip. We're already seeing this with new sensors that have dedicated AI processing power built right in. This means the sensor itself can analyze a scene in real time, identifying objects, faces, animals, food, and optimizing the camera settings before the photo is even taken. This is faster and more efficient than sending all the data to the phone's main processor. Another exciting area is 3D sensing. Sony is a leader in what's called time-of-flight, or TOF sensors. These special IMX sensors don't just capture a 2D image, they work like radar, sending out pulses of invisible infrared light. This creates a highly accurate 3D depth map of the environment. This technology is crucial for things like portrait mode. It's also the key to unlocking better augmented reality, or AR, experiences. This fusion of advanced hardware with on-chip intelligence is what we call computational photography. And it's the future. Imagine a sensor that can automatically track a moving subject and keep it in perfect focus without you doing anything. Looking ahead, the goal is to make a camera that sees the world more like the human eye does, or even better. We can expect Sony to continue pushing the boundaries with new sensor structures, like the recent two-layer transistor pixel technology. The ultimate camera will be a seamless blend of incredible hardware and powerful, on-chip AI. The Sony IMX sensor started as a piece of hardware that captures light, but it's evolving into an intelligent eye that truly understands it.